Hey guys, welcome back to another video from Beyond the Five. Today we are going to be getting into chapter 3.9, which is the separation of solutions and mixtures in chromatography. So the enduring understanding is that interactions between intermolecular forces influence the solubility and separation of mixtures. So how can two solutions be separated? There are two ways that you can separate a liquid and then analyze it. So not through filtration to analyze it, but through chromatography or distillation. These are processes that take advantage of differences in the intermolecular interactions of the components. And so starting off with chromatography, chromatography, which is the paper one that we're going to talk about, separates chemical species by taking advantage of the differential strength of the intermolecular interactions between and among the components of the solution, the mobile phase, and with the surface components of the stationary phase. So we're going to talk about what those mobile phase and stationary phase words mean. And so here on the left is just a basic setup. So we have the chromatography paper, we have the solvent front, and we have the start line, and of course the direction of motion of the solvent. And so on the right side, these are just some aspects of this chromatography lab. So the solvent is also known as the mobile phase. So what they mean here, the mobile phase, they just mean the solvent. The chromatography paper is also known as the stationary phase. So talking about that here, that's just what they mean. And so once the stationary phase is dipped into the mobile phase will pick up particles from the mixtures labeled A, B, C, and D. So all of these are mixtures. These are mixtures, separations of solutions and mixtures. We're going to be talking about mixtures here. And so the solvent can be polar or not polar. If the particles in the mixtures are the same polarity as the solvent, the particles will be carried farther upwards. So that's why in this definition really of the different strength of intermolecular interactions, that's where that polarity comes into play. And so if the particles are larger, their movement will be slower, so they won't move up as far, or they might just move slower. And the mobile phase, based on these two factors, will thus carry the particles at different rates. Just for credit purposes, these last three bullet points were created with help from Sean Byron at the College Board. And so here's another setup. Again, you can see the chromatography paper, the solvent front, the solvent, but now this is really after the experiment has taken place, and this would be maybe around 4 or 5 minutes. And so then we have this analyzation. We have the solvent front from the origin, and you can see these different distances. So what do they mean? So right here we have this RF factor, which is the distance traveled by the particle over the distance traveled by the solvent. So if we wanted to analyze the RF factor for purple, it'd be 6 divided by 10. And so if two dyes or samples on the chromatography paper have the same color and the same RF value, you can make the assumption that they are the same compound. It is not 100% foolproof, but it's a good indicator. And so next we have distillation. And so distillation separates chemical species by taking advantage of the differential strength of intermolecular interactions between and among the components and the effects these interactions have on the vapor pressures of the components in the mixture. So again, that those intermolecular interactions are still coming back to us. And so this is the basic setup. There's a mixture in a flask with two different liquids that must have different boiling points. The burner or hot plate will be set to a temperature that is in between the boiling points of the two liquids. This way, one of the liquids will be evaporated into another flask, and the other liquid will stay in the original flask. And so you'll see what I mean here. So one liquid here, and then one liquid over here. And so I'm just going to go through these different aspects of the distillation lab setup. So here's the heat source. Here's the still pot. Here's the still head. Here's the thermometer. This is the condenser, so this will cool down the vapor and then put it into liquid. And so there will be cold water coming in and cold water coming out, which helps cool down the vapor. And then here's the receiving flask. And this is just a gas/vacuum place of entry. Here's the still receiver. This is the heat source, and then this is the stir speed control. And this is just, this whole entire thing is the hot plate, which can also be called the stir. So the stronger the IMFs of a liquid, coming back again, the higher the boiling point must be to separate the liquid into the receiving flask. And so if you wanted a review, or you thought this might have been confusing, or you wanted some practice with this, I would really recommend watching this video from the College Board. It's a really great video, and it might clear things up for you, or if you thought this was clear enough, this would just be a good review. So feel free to watch this, and here's today's bibliography. And I will see you guys on the next one.